Okay, so pretty much if you are a calorimeter, that's what your job is. Like, what do you do? Well, I do calorimetry, right? Pretty much if you do calorimetry, the thing you want to do is be a bomb calorimeter, okay? Bomb calorimeters actually get to blow stuff up and measure the heat that's put off by this, okay? And this is how they determine the energy content of food, right? Is they actually take, like, maybe if it's a candy bar, right? You just take a little piece of it like that and take that and stick that in this little cup there, right? And they stick it in there, they seal it in here, and then they pump in, I think it's about 20 atmospheres, 30 atmospheres of compressed pure oxygen, right? And here's the deal. I mean, anything that has food energy will just burn, right? And the heat released by burning it is the same heat your body can get because your body oxidizes it essentially, right? Um, and so what they do is they make sure that the limiting reactant is not oxygen. They make sure the limiting reactant is the candy bar, right? And the other thing you need to know is that anything that burns in air will fabulously explode in compressed oxygen, right? It's very, very dangerous. This is why even if when you could smoke in hospitals, you never could smoke in hospital rooms where there was oxygen present. It's terribly, terribly dangerous, right? Anyway, this thing here, you put this is the bomb, right? And the bomb would be placed here. This is it right there inside a regular calorimeter. There's a beaker with water, right? We're going to fill it with water, and we've got these little things here. This stirs it so that the heat can flow quickly from the aluminum to the water, right? Okay. And I think I've said everything I need to say. Yeah, there we go, right? And if we just measure the temperature rise here, right, we can measure the heat that flowed out of the candy bar. Okay, so I'm just going to do an example of this for you. Okay, here's a piece of a candy bar, not the whole candy bar, right? It's placed in this calorimeter, and it's surrounded by this much water. And I guess we're not going to worry about the glass beaker. It's a styrofoam calorimeter or something like that, right? And so all we're going to do is just MCAT this. We're going to do MCAT plus MCAT, right? MCAT of the water plus MCAT of the aluminium, right? So the water is, let's see, 2.150 kilograms, right? And the C of water is 4186 joules per kilogram degrees Celsius. And then the temperature rise is, let's figure that out. What's 33.12 minus 22.25 is minus 22.25, 10.87. Is that right? Okay, so this is times 10.87. And then the aluminum is 3.687. And then aluminum's specific heat is right there, right? Right, and then the temperature change is the same temperature change, right? The 10.87. Okay, so let's do this 2.15 times 4186 times 10.87 plus 3.687 times 900 times 10.87. I'm getting a slightly different number than I got before. That's interesting. Okay, so I get trying to see if I made a mistake. I don't think so. 133898. 0.834. Okay. Let's see. Hold on. Okay, there it is. And then 33.12. I'm just double checking, making sure. 22.25. Yeah, that's good. Okay. Okay, so that I'm confident that this is the right answer. That's how many joules it's absorbing, right? Here I said 134 kilojoules. Let's see, 1, 2, 3. Yeah, I guess we'd have to, if we divide it by 1,000, we would get that, right? Which is about 134 1,000 joules, right? And then it says, what is the caloric content of the entire if the entire candy bar has a mass of 35 grams? Well, this is joules. So the first thing I want to do is set up a proportion, right? 133.898 kilojoules is to 3.215 grams, right? As X is to all 35 grams, right? So I'm going to take this number I've got, multiply by 35, divide by 3.215, and I get, wow, it's just a lot. Okay. I get 1457.68 kilojoules, right? Kilojoules would be in the whole bar, and then I'm going to divide by 4.186 to get calories, right? By 4.186, and I get 348, so not 349, but 348. 348 big C's for the whole candy bar. Yeah? Someone set up us the bomb.